Today we will find the relation between angle of scattering in lab frame as well as in center of mass frame. So topic is relation between angle of scattering in lab frame and in center of mass frame. We will find the relation between angles, that is angle measured in lab frame and angle measured in center of mass frame. We have to find the relation between both. Let me know that it is u1 is the velocity in lab frame and v1 is the velocity in lab frame. It is before collision, it is after collision, and the angle between these two velocities is phi. There is angle of scattering in lab frame. So this is diagram. This is a diagram for lab frame. And similarly, if we study this diagram in center of mass frame, then the velocity become u1 dash and it will become v1 dash. It is before, it is after, and the angle between these, let the angle between this u1 dash and v1 dash is theta, and it is center of mass frame. So we have to derive the relation between theta and phi. So article is to find the relation between phi and theta. So what is phi, what is theta? It has been defined by the concept of velocity before and after collision. Now we will use the concept of vector product. First of all, I will consider in center of mass frame, the velocity u1 dash and v1 dash makes an angle theta between both. Therefore, we may write it as u1 dash dot v1 dash, that is vector A dot vector B is u1 dash magnitude and v1 dash magnitude and cos of theta, because the angle in this case is theta. So this is our first equation, that is we have used the concept of product of two vectors, that is vector A dot vector B is equal to vector A magnitude and vector B magnitude and cosine of angle between both vectors. And similarly in lab frame, lab means laboratory frame, in this case the velocities are u1 and v1, and again it is product of two vectors, so it will become u1 magnitude into v1 magnitude into cos phi, because the angle between u1 and v1 is cos phi, that is angle phi. So these are the two formulae, two equations, first and second equation. In first equation I have used the angle theta, in second angle is phi. Now we have to derive the relation between both theta and phi. It means we have to merge these two equations into a single equation. So there are different methods to merge these equations, and the preferred method which has given in the book is that we will convert or reduce this second equation by using first equation. So from equation number 2, what is cos phi? Cos phi is equal to u1 dot v1, this one, over u1 magnitude into v1 magnitude. Okay, it is cos phi, this one. Now we will convert the right hand side into theta form. So we will prefer, or we will convert this u1 in u1 dash, v1 in v1 dash, so that we can use the formula of this dash, that is in terms of theta. So what is the method to convert these velocities into dash frame? So we know that u1 is equal to u1 dash plus v. u1 is equal to u1 dash plus v. So what is v? V is the velocity of center of mass. So I have already proved this formula in the previous article, that is u1 dash is u1 minus v, or u1 is equal to u1 dash plus v. And similarly v1 is equal to v1 dash plus v. So what is v? Here v is velocity of center of mass. Velocity of capital V is velocity of center of mass, and u1 is the velocity of first particle before collision in lab frame, and v1 is the velocity of first particle after collision in lab frame, and u1 dash is the velocity of first particle in center of mass frame, and v1 dash is the velocity of first particle after collision in center of mass frame. So these are the relations we have already read. Now we will put or convert this formula, that is cos phi is equal to u1. What is u1? It is u1 dash plus capital V dot v1, that is v1 dash plus capital V over u1 means u1 dash plus capital V mod v1 dash plus capital V, v1 dash plus capital V. So I have done nothing, I have only put the values of u1, v1 in this equation. So now this equation is converted into the equation of dash, that is in center of mass frame. Now multiply these terms. First we will get u1 dash dot v1 dash plus u1 dash into v, u1 dash into capital V, and plus capital V into v1 dash dot v1 dash, and plus v dot v, that is v square. We both are same, so it will become square. And in the denominator, let remain the term same. I am not putting the values of these terms, that is v1 dash plus v. Is it clear? Now convert or put the values of these u1, v1 dash in terms of theta on right hand side. So therefore cos phi become, so what is u1 dot v1 dash? So we know that it is u1 dash magnitude into v1 dash magnitude into cos theta. So in this way I have converted this value in theta form, the first term, and for second term and third term all terms remain same. So u1 dash dot v plus v into v1 dash plus v square over this u1 dash plus v into v1 dash plus v. So it is capital V. Capital V is the velocity of center of mass. Now we know that as we have studied in the previous article, that u1 dash and v, u1 dash and vector v means velocity of center of mass and the velocity of first particle in center of mass frame are in same direction, means the angle between these two vectors is 0 degree. Same direction means angle between these vectors is 0 degree. So therefore, this term u1 dash dot v, this term, because angle is same, and it will become u1 dash magnitude a dot b, a magnitude into v magnitude into cos of 0, and cos 0 is 1. And similarly, this plus u1 dash plus v magnitude. So what is the value of this magnitude? We know that vector a plus vector b magnitude is under root first square, that is u1 dash whole square, and second v vector magnitude square plus 2 u1 dash into v into cos of 0 degree, because angle is 0, so it is cos 0. We know that cos 0 is 1, so it will become the complete square of u1 dash and v. So this whole term become u1 dash plus v whole square, and whole square will cancel with the square root, and finally we will get the value of this term u1 dash plus v is equal to u1 plus v magnitude. So this is independent. So in this way, these terms are obtained. So these two, and remaining term these two. So we know that the angle also we know that the angle between vector v and v1 dash is theta. It is same angle which is between u1 dash and v1 dash. So the same angle is formed between center of mass and velocity of first particle after collision in center of mass frame. So therefore, what is v dot v1 dash? It will become v magnitude into v1 dash magnitude into cos of theta, cos vector a dot vector v vector v magnitude into cos theta. And similarly, v1 dash plus v, its magnitude is under root first square v1 dash mod square plus v mod square plus 2 v1 dash mod into v mod into cos of theta. So this term remains as it is. So now we will put all these values in this equation. So this equation is the master equation, that is cos phi equation. So we will put the value of these two terms, this term and this term, and we finally got the equation in terms of purely theta. So we will get the theta equation. So on putting and solving these equations, we will finally get cos phi is equal to sin theta over cos theta plus v upon u1 dash. So finally, we will got this the vector, these are scalar quantities. So you can solve by yourself on putting these values, which I have already proved, and putting these values and solving all these equations, you will find this finally result. And similarly, also we can find this equation, or either this or this, sin theta over cos theta plus v over v1 dash. So these two possibilities are there, which derive the relation between sin theta, theta and phi. Sorry, it is not cos, it is tan. Tan, it is also tan. When you solve these equations, and you will finally got this answer. So I have not solved this equation, you can solve by yourself from the book, and finally you got these results. If the masses are same, or by putting the value of V, then you may simply got the answer. Tan phi is equal to sin theta over cos theta plus m1 upon m2. That's right. So this is the final answer. So this answer is representing the relation between phi and theta. So you have to remember this equation. Tan phi is equal to sin theta over cos theta plus m1 upon m2. So this is the final answer, or relation between angle of scattering in center of mass frame as well as in lab frame. So this is final answer. Thank you very much.